much harder examples. So now I'm going to take another quadratic equation which is a little harder from the previous one. Okay, it's not a little harder, it's a little different, but now you're going to get the confidence of completing the square, okay, of any quadratic equation. So let's take the next example. Let's take the next example now. It's very simple. Okay. So let's go. Okay. So you have x squared, okay, minus 4x minus 5 equals 0. Okay. So now, before you guys start on this, there's one thing that I want to tell you. That guys, that whenever you see, guys, whatever value is in front of x, when we have to complete the square, we always take half the value, okay, and then we square half the value and plus and minus that value, okay. So let me just show you what I mean. So here basically x squared. So when we multiply 4 by a half, or we divide 4 by 2, what do we get? We get 2, isn't it? So that is why here, this is going to stay as it is. And then here we're going to get 2 square minus 2 square minus 5 equals 0. Okay? That's what we're going to get. So now basically guys, what do we get? We get x squared minus 4x plus 4 minus 4, okay, minus 5 equals 0. So basically now what happens guys, what happens? So now like I said, we've already made, like I said, if you want to complete the square, you have to make a perfect square. So we made the perfect square, isn't it? So now, because there's a negative right here, we're going to have a negative here, remember that, okay? So now obviously, when you square this, you're going to get that obviously. I'm sure you know that, it's common knowledge. So this is minus 9, this is equal to 0. Okay, so now, you can transpose 9 to the other side. So because it's negative on the left hand side, on the right hand side it's going to be positive. Okay, so 9, okay. And now you have x minus 2 square, which gives you 3 square. I could have taken the square root on both sides already, but I thought why not just show you how this works. Okay, so now what is the next step here? What is the next step? Now remember what I told you guys, that whenever you have a square, you have to cancel out the square. How do you cancel out the square? By taking the square root. Okay, in the previous example I was struggling to explain this. I wasn't getting the words that I wanted to explain it, but fortunately it's not the case anymore. Okay. So now remember, we don't have 3 squared. Okay, we have 9. Okay, so this is 9, this is not 3. Many people will confuse. Okay, so when you take the square of 3 square, what do you get? Or when you take the square root of 3 square, what do you get? Or when you take the square root of 9, what do you get? You get 3, isn't it? So that's how it is. Okay, so now it's a piece of cake. Now it's become a quadratic. Now it's become like a linear equation. But guys, don't forget, plus minus 3. Okay, remember what I told you. Minus 3, if you square minus 3 and 3, you're going to get 9. So that is why you have to have plus minus 3. We're finding two values. Okay, so now basically you get x equals 2 plus minus 3. Okay, and now this is easy. 2 plus 3, which gives you 5. Okay, 2 minus 3, which gives you negative 1. Okay. Okay guys, so this is how this problem has been solved. So now let me just tell you one more thing before I go to the next example. I feel I probably missed out a few things. Okay guys, so whenever you have to complete the square, okay, so guys, you always look at the number in front of x. Okay, so now you have two options. You have to find half the value of whichever number is here. So you have two options. You can either say, okay, I'm going to divide that number by 2, or I'm going to multiply it by half. Okay, whichever method you find easier, just use that. Okay, whichever method you find easier, just use it. Okay, it doesn't really matter, it's one and the same thing, but I thought, why don't I just tell you? Okay, so I hope you've taken this down. Give it 2-3 seconds more. So let's do the next example. Okay guys, so the next example is a little more complicated, but hopefully you are ready for the next example. Okay, so right now guys, the examples I'm taking are very easy. Okay, I'm taking very simple examples. Now the reason why I'm taking very simple examples in the beginning is because later on, these quadratic equations will become so complicated that if you do the hard ones now, you're going to find it difficult to find their answer. You're going to find it difficult to solve. So I'm starting with the simple ones so that you get enough practice and confidence and you can move on to the next. Okay, let's take the next example. So x squared plus 5x, okay, yes, minus 14. Okay, so how will you do this now? Okay, how will you do this? Just try by yourself. Okay, I want you to try a little bit by yourself and then we'll do it together. Okay, but I want you to try this by yourself. Okay, I mean, at least start off by yourself and then we'll solve it together. Okay, I'll give you 2-3 more minutes. 2-3 more seconds. Okay, so let's do it. I'm sure you've already gotten started on this. So now guys, obviously there's nothing in front of x squared, so you can't divide by anything. So no point in doing that step. Okay, in the next example, there's going to be a number in front of x squared. So I've alerted you before. Okay, so now everything depends on the number ahead of x, which is 5. So basically, you have two options. You either divide 5 by 2 or you multiply it by a half. And we already know. Basically guys, you have two options. You either divide it by 2 or you say this. Okay, but it does not matter because you're going to get 5 by 2 at the end of the day. Now whichever way you feel comfortable, whichever way you're used to doing it, just do it. Okay? Whichever way you find it comfortable, just do it. So that's the step. So let's do it. Okay? So now obviously we have to take the square of this now. Minus 14 equals 0. Now obviously many people will be like, after I get the perfect square, why don't I prove how I got the perfect square? Guys, you don't have to prove that. That's not important. In the derivation, it's just explained like that so that it's it gets stuck in your mind and you don't forget. But here you can directly do it like this because it's a matter of common knowledge. Okay? It's a matter of common knowledge. Okay? So now you have 25 upon 4 minus 14. Now I hope you understand how you get this. Basically guys, there's a law. Okay, I'm sure you know the law. Let me write it down. This is the law guys. A-N-B-N. Okay, I hope you understand that law. That's how you get this. Okay, so now you have x plus 5 upon 2 squared. Okay, So now obviously guys, the LCM is 4. 4 divided by 4 is 1. So you get 25. Okay. And then now 4 divided by 1 is 4. So 14 into 4 is how much? 14 into 4 is 56. Okay. Divided by 4 equals to 0. Okay. So now you get x plus 5 upon 2 square minus 81 upon 4 equals 0. Okay. So this is where we have arrived. Okay. So now from here, I'm sure you can take it from here. What do you do now? So now guys, we have to cancel out the square. So in order to cancel out the square, we take the square root. Okay. So then here, when we cancel out the square, we're going to be left with, okay, x plus 5 upon 2. Okay, and here on this side, what is going to happen? So basically, before we cancel out the square, let's just take this to the other side. Okay, so because it's negative on the left hand side, on the right hand side, you substitute the value on the right hand side, and you inverse the sign. So basically, it's going to be positive. Okay, so now what do? Now we have to cancel the square. Okay, so to cancel the square, we take the square root on both sides, and what do we get? We get x plus 5 upon 2, okay, which equals plus minus 9 upon 2. Now one more thing that I want to tell you guys is, as you're completing the square, once you cancel out the square by taking the square root on both sides, if you do not get the same denominators, then you've made a mistake somewhere. Okay, you've made a mistake somewhere. So just remember that. Okay, I've practiced this concept enough to really know that. So just keep that in mind. Okay? And sometimes guys, it can be possible that you've got the right denominators, but because